like magnitude and vector. Vector are those one which have like magnitude plus standard direction too, but magnitude are only one which have like only themselves, but vector is them and the direction too. So supposedly if you talk about like speed is like magnitude, because there is no direction in speed. But if you talk about displacement, which is like how much distance you have covered in like the shortest part to it, that have like magnitude plus your direction, because you are going from point A to point B. Then uh, then there is period method, whereas time period is there. And period method is saying like if this is supposedly the sun, then if this is the earth's orbit and this is the earth here, then after the period of 365 or 366, depends on the leap year, this earth would be at this period all like again. This is called periodic motion. Periodic motion in which like the object object comes back to the original place from where he not he but it started. That is periodic motion happening in a period. Again, I another example is like a pendulum. It would like sorry, it comes from here only. So like it would be here also, it would be here also, there is a period here, right? So that is a periodic motion basically. Now there is non-periodic motion which are doesn't follow this periodic thing, which they doesn't come to their original position. That is a non-periodic position. Now, on basis of time, uniform motion is equal in distance and time, and non-uniform motion is unequal in distance in different time. So, like if you're talking about like uniform motion, right? So like from uniform you are getting an idea of everybody would be same, right? A uniform is issued to a school uh, in order to every student look same, right? So uniform motion would be the similar thing. If it is that, then the like supposedly this is the car, right? Then this car would have traveled like this car would have traveled supposedly this much distance a, and the car b would have traveled the similar distance which is the b, but they're like the distance is equal, right? So this is uniform motion and they did this thing in like in equal time too. So this is uniform motion, and non-uniform is basically you are not doing the your motion or whatever in an equal time and not an equal distance. Basic stuff I would say. Then if a athlete, so like from this type of thing, like from uniform motion, if you are a like a healthy person, then you would uh, you all would like go to grounds, right, for running and all that. So supposedly this is you running on the track, right? You ran this track for like 400-meter track, right? You ran this whole track and you came back here. So you did a uniform motion, right? So when you did this uniform motion, this basically if there's a question like if an athlete does and running in 60 seconds, so it's this 400-meter he's doing in a 1 minute, which is pretty impressive. What his distance and displacement is in 4 minute and 15 second. 4 minute and 15 second he's asking. He asked me distance and displacement. Now distance is the like the regular path. So distance is like this whole track you are running from point A to point B, point A to A originally. So like if you ran this whole thing from point A to point B, and then that is your distance, right? So here the distance, you could find it like if 60 second is giving you 400 meter, then if 4 minutes is there, so 4 into 4 is what? 1600 you did, plus you did 15 second or something like that. So here the distance would be like your 16 15, yeah, 1650, something like that, right? Now the displacement, if you talk about here, then if you supposedly starts from here, and your track is supposedly ending here, so like if you are going the full distance, then that's distance. But if you are going from displacement, that's the shortest path from for the point A to point B. The shortest path is this, right? This hypotenuse, right? This is perpendicular, this is base, right? Now if you look at this, then the distance along the edge of the circle is 2 pi r, because like the area of the circle is what? Pi r square, right? The circumference of the circle is what? 2 pi r, right? Now the whole like the circumference we will run, right? Only we will not run on the area, that is different, right? We will run at the outer edge of the circle, right? So that's why we took 2 pi r. Now when we took 2 pi r, that means like it would be like 2 into, what is this? Okay, so like here like we got like 4 minutes and 15 second, right? So 15 second would be converted into minutes, so it would be 15 by 60, which is 1 by 4. So like 4 1 by 4 is your what? 17 by 4, right? Now this 17 by 4 is the whole time that you took to cover the whole distance around the circle. That was the question, right? 4 minute and 15 second you took to cover the whole distance, whole this. Then you want to find that, right? Now the whole time you took was 17 by 4 into 2 pi r, right? Now this got cancelled, this became 2, then this get cancelled, this is 8.5 pi r, right? So that is your whole distance thing, right? Then you get the radius and you just put it in the equation. That's the displacement. Distance is the one that I already told you. Now if we go ahead, the average speed is equals to total distance upon total time. So average speed, so like average speed of the whole journey would be taken out by total distance upon total time that you took, right? Now instantaneous speed, like instantaneous, they are saying instant. Like if you are here point A, then you zoomed here to point B, that is instantaneous. So that would be on change on velocity or whatever, right? Change on like the this is the velocity, right? What would be the velocity or acceleration, right? So change on displacement, the distance cover, so point A to B would be displacement. Change on displacement by change on time. Displacement we took because like we went from point A to B, that is distance, right? That's why change in distance upon change in time, that is the v here. Now like now we will do average velocity. Yeah, average velocity also have like formulas like 2v1 v2 by v1 plus v2, and this is for equal distance. and the v1 plus v2 by 2 is on equal time. These are the two, right? So v 2 v1 plus sorry 2 v1 into v2 by v1 plus v2, and it is for like the distance is equal, then the v1 plus v2 by 2 is for your equal time. Then now there are some basic formulas like v is equals to u plus at, then s is equals to ut plus half at square, then v square minus u square is equals to 2as. So if I have to tell you these formulas, so like supposedly this is the guy, right? He threw a ball up in the air and the ball trajectory came down, right? So we have the ball at 3 point, it just went that trajectory. So v means your final velocity, and u mean your initial velocity. So like v means the final and u mean the initial, which is the starting. So starting here, u would be max and v would be minimum, because max, because like v is the starting, that's why it is max, and u is the ending, so that's why here it is minimum. Here the u would be 0 and v would be max, because that's the final position, and this is just the ending point, right? So with that, so like v is your final and u is equals to initial. So here also you will always subtract from final to initial, right? Now some distance time graph, right? And also if you want to find the distance traveled during the nth second, like sub specific second they are asking what is the distance there, then it is equals to u plus half a to n minus 1. So u plus half a to n minus 1, so u plus half a to n minus 1, right? Now uh now the distance, like these graphs, first off is the what is this distance diagram or something, this one is your this is the graphs on this one, and these graph, like these equations graph. So v is equals to u plus at, the first one is this one, which is the thing going here, and it is time written here, and this is acceleration, right? Now if the acceleration is the constant here, basically it is just telling that. Now this is the distance and this is time, this is basically telling that the distance is increasing. uh, Now s is equals to u plus half at square, right? Now here also the distance is just increasing. Now v square minus u square is equals to 2as. Here also distance is increasing, right? In all the equation, it always constant to that equation to work. In all the equation, a is equals to 2 is always constant to this equation to work. So like in this thing, like the acceleration time graph is always constant, that's the whole thing here. Then now it is talking about circular motion and tangential motion, if I have to say. So like uh, supposedly this is the sun and earth orbit is elliptical. uh, like This is perihelion closest, this is aphelion, right? So when the Earth is the closest to perihelion, which is the closest point of Earth and Sun distance, so at when the Earth is going towards here, it is doing a tangential motion, right? In this motion, the Earth is trying to go out, flowing throughout, and the centripetal force is driving it in, right? And the gravitational too, but the Earth acceleration is like 30 kilometer per second. So like a finger snap and Earth move 30 kilometer. So that is what keeping Earth from not going towards the sun, it just going out. But the Earth, like when it spins, so it spins like this, right? So it is doing a tangential motion outside, it's trying to go out, but the gravity and the centripetal force of the sun is like holding us in the Earth's orbit. Now uh, now if you have to talk about it is just saying that inertia is proportional to your mass. So inertia is basically, like, you have heard of this very frequently, but like inertia basically mean like Earth is there, right? How much force Earth need, or like how much strong Earth is, like how much force that Earth need to move from the orbit, change the orbit, like how much mass that it need. So that is inertia, like how hard it is to change the path of an object, that is inertia. And mass is basically, in mass there is no gravity, which is 6.67 into 10 power minus 11 uh, into m upon r square, something like that, through which you take out a planet uh, weight. But here mass is there also, right? So mass is something which an object have, which doesn't equivalent to its weight. Now Newton, like the law of motion, which is like force is equals to mass into acceleration. So what it is saying is like force, force, like force is there, right? What does the force mean? Force mean like this is the guy, right? And he is pushing him, right? So he also have a mass and he accelerated towards him to push him, right? So force is equals to mass, not weight, only mass into acceleration. Now its SI unit is your kg meter per second square, minus square. And minus is because like it is like usually like kg and upon m, so it goes up to, it becomes minus. Now here is also one more thing, which is dime, dyme. So a dime means like it is a CGS unit, centimeter gram second, CGS unit. And it just says that how hard it is to move 1 centimeter, that is the whole dime. So 1 dime is equals to 10 power 5 minus 5 Newton, or you could say 1 Newton is equals to 10 power 5 dime. So if it would be asking like if a scooty, if how much force is recorded in accelerated of 5000 kg car at 6 meter per second, so that's you just do 5000 into 6, which is 30,000 Newton. Now here is like a famous question which usually comes in the exams, which is like you would be given like the motion of a particle of mass is described by y is equals to ut minus half gt square, right? and it is saying where u is the initial velocity that we know and v is the final, right, of a particle, force acted upon it is. So they are asking specifically about force acted upon it, right? So what is the formula for force? Force is equals to mass into acceleration, right? So force acted upon it. So first of all, you would look at you know how like in like v is equals to u plus at. When we talk about gravity, we just do g, right, which is 9.8 or 10, you could say, for your sahuliyat. uh, so like we just used gravity here. Gravity is here in the quotient, so we will just put gravity also here, which would be mass into gravity, right? Now if I'm seeing in the option, there are two options which are matching. Force is equals to mass into gravity, force is equals to minus mass into gravity. Now coming back to the quotient, u is equals to ut minus half gt square. In this, what you have to do is that you have to differentiate. If you know, you would have studied in 11 12. I also didn't study it, but I studied it as separately. So like ut would become u, right? Because like if it is like x square is there, right, so square you put ahead, which become 2x, then do you put it ahead, which become x, right? You just like differentiated. This was discovered by Newton when he was like 26 or something like that. Ut, right? U minus half would go like he would be not there, so like now it is gt, not 2gt, right? Now it becomes minus gt. Now it became minus g, so u is equals to minus g. So we had options f is equals to mg and f is equals to minus mg. Now we will correspond to this as f force is equals to minus mg as the answer, and that's the answer. Yeah. Now we know the formula. Force is equals to mass into gravity or mass into acceleration, depends on the quotient, right? Now if it is like a basic quotient, which is like supposedly a person is here applying 15 newtons of force is applied from here, and here is like 10 newton force is applied, and here is like 20 newton force, and here we don't know what is the force applied, and they are asking that what would be the force that would be necessary to both of like the to block to like this cube or rectangle, whatever this is, to stay in one place. So like this is basic question, this becomes 25, this becomes 20, so here is a difference of 5. So this would be 5 newton of force would be applied by this question mark here. So this is a basic question in this thing. Now if the question asks you like a block of mass, of 2 kg, 2 kg moving in a initial speed, initial means starting speed of like 3 meter per second. From starting speed, as I told you, it is u, right? Now it comes to a rest. So now it is coming to a rest. So when you come a rest, you don't comes to a rest at the start, right? You comes to a rest at the end. So that would be v is equals to 0. Now it is saying a rough horizontal surface, like khurdura surface, after distance, which is s, distance is usually s in this type of formula, which is 3 meters, and the magnitude of the frictional force. So like it was like a bicycle, you could imagine. My drawing is bad on the bicycle. This is the bicycle, right? You could imagine it. I made a treadmill. So like a bicycle is there, right? So it was going, and supposedly you saw a child crossing the road and just press the brake really hard, and now it is saying what would the force there, right? So first of all, force is equals to mass into acceleration. First of all, see what we have to find, right? We have given mass, right? We have mass here, right? Now we have u here and we have distance here, right? And we have v here also. So we can apply a formula which was v square minus u square is equals to 2as, right? So v is 0 minus 9 is equals to 2 into acceleration we want to find, and distance is 3. So distance is 3, right? Now it becomes 9 as 6 and a. So a would be 9 by 6, 3 by 2, which would be 1.5 in minus. So that is here acceleration. Now acceleration is going to be here. So it is in minus because like we've applied a lot of force and we just stopped, right? So now we are going here. So force is equals to mass, is it is 2 kg and this is 1.5. So this comes out to be 1.5 into 2, 0.13. 3 newtons of force would be applied by your hands to press that brake to save that child. So that's the question there. Now another question we are gonna do, which is saying a car of 1,000 kg. So supposedly this is the car, right? And this car is your of 1 ton, or you could say 1,000 kg, right? Now if the car is 1,000 kg with a uniform velocity, so uniform mean, as I told you, when you issue a uniform, that mean you want everybody to be same. So when you talk about uniform velocity, they are saying 72 kilometer per hour. So in an hour it would go to 72 kilometers on towards a straight road. So the road is also straight. The driver presses brakes suddenly, the same type of question, and stops. The car stops in 0.25 seconds, right? Now the retardation force, like retardation mean the deceleration, retardation force applied is. So first of all we will see what we have to find. Force is equals to mass into acceleration. This is the basic question. Now we have given here is your time, which is here, and we have this, which is the 72 kilometer per hour uniform velocity. So this basically means like u, right? Now when we do it, when we are now we are going to do it. So like we have time. Now earlier I applied this formula because we and you was given. Now there is no like we have been time issued here, so we would utilize that. So v is equals to u plus at, right? Now v is 0. Now u v is 0. What did I ask? Said v0. Yeah, we would be 0 because we stopped at the end, right? That's the whole idea, right? So u was like 72 kilometer per hour, and this time is in seconds. So that's a problem here. So 72 into we will do 5 by 18. So like bade se kilometer to meter would be 5 by 18, and meter to kilometer would be 18 by 5. Bade se chota, then bada would be ahead, 18 by 5, right? So 15 by 8 because we are making 72 kilometer by we are making in these seconds, right? So this would be like 18 4 is 32, yeah, 4. Then this is 20 meter per second, right? So 20 plus acceleration we don't know, into time is 0.25. Now this would be coming out as acceleration is equals to what is this, 20 into this 0. So it would be coming out to be like 20 into 0, like 100. So after 100, so like 1,000 kg into 100 would be like 1 2 3 4 5. So it would be like 1 lakh, or you could say 100,000 in English, or you could say 100 k for 1,000 as Newton. And Newton unit is kg meter minus this. Now we are talking about momentum. So momentum, Momentum basically means the measure of quantity of motion. Momentum means like motion. You're doing motion, right? Motion of an object at a specific instance. That's the momentum. Now, momentum is identified as P as its symbol. Now, P is equals to the momentum would be happening when where? When would be the momentum happening? When a body is moving, right? So body has a mass and movement is a velocity, right? So here automatically formula would be mass into velocity, right? Momentum is equals to mass into velocity. So that's not hard. Now ahead we had for force we had kg meter minus square. Here we would had for its SI unit as kg meter uh, kg meter per second minus 1. This was usually like this, so it just came here so to make minus, right? Now this is also a vector quantity because momentum has moment and it has a velocity, it is going somewhere. Now there's a law which is says that force is inversely proportional to uh, change in momentum, not sorry, proportional to change in momentum and inversely proportional to change in time. So like if you increase if you like the time like the time increases, then the force decreases at the like longer duration, right? Even in the earth, like if the sun dies, then the force would be which is making the earth revolve would just end, right? That's the whole idea here. Now there is also like this force formulas for like rockets and all that. So force is equals to velocity upon this is change in mass upon change in time. So change in mass and change in time is basically here because like this is the rocket, right? Now the rocket have a propeller here and propeller here. At the start it this one doesn't even like launch starts. This is going on, right? Now when you go like out of the space, first of all earth escape velocity is 11 kilometer per second. Now if you are like when you are at a certain distance on the atmospheric layers like troposphere, trust stratosphere, mesosphere, like these spheres you are there, supposedly these two get detached because like they have done their work. Now that change of mass, they had a mass here, right? Oxygen and their oxygen and like hydrogen and all that were burning here, right? They have their own oxygen tank, right? So they had a mass rate, right? So their mass, they got detached, so their mass got decreased. So change in mass. And for change in time, the time also changed, right? At this, like they were here at the start and they were here, so change in time into velocity, what was the speed, is equals to like the it change in mass over time, likes in rocket. So this is the force which would be applied in the rocket over some period of time. Now we will talk about impulse. Impulse basically means like change in momentum over period of time. How much the orbit have been altered, change in time. So impulse change in time, I is equals to, okay. So impulse, first of all, its symbol is I stands for force into change in time. So force also stand for mass into acceleration. So impulse basically mean this is the earth orbit, right? This is earth, right? It is going here, right? So impulse basically means like supposedly like some asteroid like hit it earth here, right? So it deviated earth's orbit a little bit, right? So over time it comes to back towards its original place, right? A little bit it got deviated. So like over this period of time, What was the change in momentum? It is basically called impulse. So that's the whole thing here. And if you got confused in momentum and impulse, the basic idea here is that momentum says that how much the plane has been altered from its orbit. So like how much the plane is has been altered from the orbit, and impulse talks about how much the planet have been change in time for its orbit during the period of time. So like momentum talks about like at a specific point, and impulse talks about like a huge time, how much would be the like effect on the earth's orbit. So that's the whole idea here. Now if we gonna look up question here, which is saying a hockey ball of mass 2 kg traveling at 20 meter per second, so u is equals to 20 meter per second, stuck a hockey stick so as to return it along the original path with a velocity at 6 meter per second. Calculate the change in momentum starts from p is equals to mass into velocity. Now there are two u's here. Okay, and calculate the change would be applied when you have a bigger quantity and it became smaller. So how much smaller it became, that is change, right? So you would have p is equals to mass into velocity, which is the big u, minus mass into velocity, which is the small u. So mass here is 2 into 20 minus uh, 2 into 6. So 40 minus 12 would be your like uh, wait a second. Am I doing wrong here? Wait. There is minus here. Wait. Let me just write the formula properly. So m is equals m into u minus m into v, right? Now if I take here something common, which is m would be like u minus v, right? So 2 is equals to, it was 20 and it was 6. So mass at 2 into 20. So stick collides with the ball at 6 meter per second, and the mass and traveling at 20 meter per second at minus, it is saying. Okay, it was saying 20 meter per second at minus, so minus is there and it is saying 6 minute. So like it, the question is saying it like this: 20 meter per second at minus, and what is this, 6 meter per second. So here it is minus 20 minus 6, which would become minus 26. Minus 26 into 2 is your 52 minus, so 52 kg meter per sec, sorry, kg per second. Now there is also one more question which is saying if 100 grams of a sphere is moving at a velocity of 20 meter per second and collides with a ball of 50 gram, and it was at the rest at the start, but after collide the ball speeds, so balls goes ahead when it collide after that. So first of all, what was the momentum of both? So p is equals to 20 into 100, so that comes out to be your 2000, which is 2 kg, not 2 kg, like 2000. Now 2000 was the momentum of the first ball. Now the momentum of like this is the momentum. Now the momentum of the second ball into this, so 2000 into 50, which was the mass, and velocity we don't know. So 50, this 40, so 40 meter per second. So like this they were saying basically, where did I start this from? Okay, so they were saying like this is the ball which is 100 gram, and this is the ball which is 50 gram. So this ball collides to this, while this ball was moving at a, what was the speed, 20 meter per second. And this ball speed we have to find after, like when they collide this ball would go flying ahead, right? Because it is a smaller ball, so we have to find this speed. So basically momentum is equals to mass into velocity. We have to find the velocity of this. So first we find the velocity of this ball, then correspond to this ball, then this ball was correspond to this velocity 2000, momentum was there, is equals to mass which was 50. So we will divide, it became 40 meter per second. Now we will talk about Newton's law of motion. Now the famous Newton law of motion, every action would have an equal and opposite reaction. So this board would go back. Famous example, right? So the formula here is P is equals to F mg into Vg plus mb into Vb. Different one, mass into velocity, mass into velocity. Now Vg, this Vg would become mb Vb upon mg minus. That's the whole formula. So if you want a question, mb is equals to, what is this, 10 gram, and its V is 220 VB, and the rifle is fired through a 6 kg mass, right? So the recoil is, so Vg they are asking velocity recoil backwards, 10 into 220 by 6000, because it is in kg. This cancel, this cancel. 11 2 11 ja 30. This comes out to be 0.37 meter per second. Now, this is a famous question, not question but equation, where force, mass into acceleration, and s is the distance, as you seen in v square minus u square is equal to 2as. S is the distance, right? So, like, what is the work done here? So, work formula is force into displacement into cos theta. Now, if you saw a cos theta like tabular form, it starts from at 0 degree as 1 and 30 degree as under root 3 by 2. So 1 is the biggest one at cos theta as 0 is the biggest, right? So at the 0 degree, basically, like if you are pushing the block at a straight angle, it would do the most work. That is what they're trying to say. Force into this would be like 1. This is the maximum things. You like the point 1 would like reduce the whole, like the sum. So at 0 it is max, and at 180 it is minimum, because when you look at the sine graph, it starts from at here, which is pi by 2, goes here pi, and goes here, which is uh, what is this, like this is pi, right? Not pi by 2, because they meet, cos and sine theta meet at like pi by 4. This is 0, right? This is pi by 2, this is pi, and this is your so here it is pi, which is the minus 1, which is the most negative one, right? So this correspond to here, which is the minimum value of this cos. Now power is equals to work into time. Work whole formula was f into displacement into cos theta. So power would be on like how much work you are doing on the time. That is the power. And now think of this like this. There is a rock here. There is a rock here, right? Now this rocks want to fall here or fall here. This rock is stable. Why is that? As you study, you should ask yourself the question, right? So the above one wants to fall because it have a lot of potential energy, as potential energy is equals to u is equals to mgh, mass into gravity into height. It has mass, it has gravity of 9.8, which is pulling it down, and it is a height, so it just want to go down, so it has a lot of potential energy. Now this is stable because like it is it is not falling down, and it has maximum kinetic energy. The kinetic energy equals to half mv square, right? And it is stable, so like because like there is no gravity which is pulling it down, it is at the maximum point of down, right? Now, if supposedly this is a spring, it is the spring is expanded towards this much distance is x, and this is a spring. So like the spring would have like elasticity of u is equals to half kx square. K is the constant which is which will be given, and x is the distance, and u is the velocity which will be coming it back. So if some elasticity question over there, you can tackle it by this. Now, work energy theorem, which says that work is equals to change in energy. Like work basically means change in energy. What does change in energy mean? This is you, right? Your battery is full, right? Now you did some work. After some time, your energy became supposedly like at this. So work is equals to change in energy. So your energy changed because you did work, right? Now work is equals to change in kinetic energy. The same goes with here. Kinetic energy would change because there's a work done applied to it. Now the other is like work is equals to change in potential energy. So the bolder example that I gave you, work which was there, work happened because the change in potential energy from the high, which is u is equals to mgh, when it go down, the height became zero. So the change of that energy is work. Like so it is work, right? So that's that. Now, if we do some question, which is a ball of a mass, 320 gram, and mass, and it has 625 joule. Joule is basically like a currency in energy. It can be used in potential energy. It can be used in kinetic energy. So it is saying it has 625 joule of potential energy, and which is revealed freely from a height. It is released from freely from a height. Basically, it is like boulder at the cliff, and it is coming down. The speed of with which it will hit the ground. So at the boom, like the thing. So that they are asking. So first of all, when it would hit the ground, the speed would be at the ground. We would not use the potential energy for formula, which is u is equals to mgh, because the h would be zero, and anything multiplied with zero would be zero. So you can't use that here, which was they were saying the potential energy is this much. The energy is there because work energy theorem was there. Like when work is equals to change in potential energy, that basically means when you are at the smashing, they are asking in the question, that basically means you have done the work and the height is zero. Now the energy would be zero. Now you have this. Now at the end, at the bottom of the hill, the kinetic energy is the max. So we will talk about kinetic energy, which is half mv square, mass into v. So mass is 320 joule, sorry, 320 gram, and velocity we don't know, we have to find by 2. So kinetic energy is 625 joule, half mass is 320 by 1000 into v square. Now this becomes 160, and if you cut this, 5 200, 5 1 5 1 2 would be 2, then 5 125, cut this again, 2 and 5, cut this again, 4 0, cut this again, 8, cut this again, 5. So 5 and 8 I'm getting, and above is 600 and 160. So 2 4s are, then 80, 4 2s are 40, then 20. So I'm getting it at like as 25 into 5 by 2 now, which is which was equals to v square. So you put an under root here, and now we will do like 625 into 25 by 4. So 625 by 25 by 4, so this would comes as 62.5 meter per second. So what we did was we took the potential energy joule to kinetic energy and just applied in the formula, like 625. If you bring it here, 1000 divided by 320 into 2 equals v square. Now v square is there, we just put an under root here, which will become 625 as 25 and into what would be this thing, 1000 on 5 by 2, 62.5. Oh, energy can neither be created nor be destroyed. This is true because when you say you created energy with your punch, that basically means the chemical energy that you got from a food, you convert it into your uh, uh, the energy that you're gonna hit the opponent. So that got transfer. It got never created. It got transfer of chemical energy to your muscle energy or whatever you call that. It never got created. It got just transfer from chemical energy, and it got to that boy, and it got him injured, and that distributed towards its bone and towards the environment. So the energy didn't got destroyed, like didn't got destroyed. It just vanished and became slowly, and it faded, and it, or you could like say it converted into heat. So energy can't be destroyed nor be created. Basic. Now power, which I told you, is equals to power is equals to work upon time. Work formula is force into displacement into cos theta, and power equals with a mass of 8 kg up an astral distance of 4 meter in 2 seconds is. So they asked me the power formula is equals to work upon time, right? Now I don't know what the work is. So uh, so we have here mass and we have here distance, and it lifted it up as 4 meter high. Lifting, so it is potential energy. U is equals to mgh. M is equals to 8. For G is not G, so G would be like, we could take 10 here, and height is 4. So 32 joule, 320 joule. So that is work. 320 joule by 2 seconds. So it is 160 power. Sorry, watt. So what I did was, these are states, right? So the more high you go, your more potential energy would be increased, right? So first of all, I calculated the potential energy. Through that, I got the joule, which is, as I told you, currency in the potential energy, work or kinetic energy. Now, power is equals to work upon time. I know time has 2 seconds. I don't know work, so I know the joule is the currency here. So I just put it there. Work on. I got that is too much for today. I'm over 1 hour. So yeah, thanks for